Let's talk about how we find horizontal asymptotes. Horizontal asymptotes are spots where the function seems to level out as it goes off towards either positive or negative infinity. So in this first example that I did, you can see 1 over x. You see that we've already talked vertical asymptotes. That's this vertical spot, basically what x's can we not plug in. And that was 0. We couldn't plug 0 in. But you also see that as the function goes out here, it seems to level out at y equals 0. It does that this way as well. And that's true. That is what's happening. It is leveling out, and it has a horizontal asymptote at y equals 0. But we can change our horizontal asymptotes a little bit. Let me show you that. So if I were to make it x plus 4 in the denominator, you can see I've shifted over the vertical asymptote to be negative 4. But the leveling off y-intercept, horizontal asymptote is exactly the same. Now, let me go to the top, the numerator, and let me change it instead of a 1 to an x. Now you can see I have shifted my horizontal leveling spot up. If I were to make this x squared in the numerator, now it doesn't even seem to level out at all. And this really is a simplified way of finding or thinking about horizontal asymptotes. Functions are always dictated, their shape, by whatever the highest power is. And we know that from working with polynomials. If you have an x squared, we know it's a parabola. If it's an x cubed, we know what it looks like. Well, that same thing is true with horizontal asymptotes. All we need to look for is wherever the highest power is. Let's do a couple examples without the graph. I've written 3 rational functions here. And let's start by just figuring out, or just kind of highlighting, where's the highest powered thing. So in this first example, x plus 2 over x squared plus 4x plus 7, the highest powered thing is the x squared, right there. If the highest power is in the denominator, this is very simple. The horizontal asymptote is just the axis. It's y equals 0. I'm going to put HA for horizontal asymptote. That means if you just think about a simple graph, I don't know what this graph looks like, but I know that it's leveling out at 0. I guess it could be above or below the axis, but it's leveling out at 0. Next, here the highest power is in the numerator. X cubed is the highest powered thing. If that's the case, if the highest powered thing is in the numerator, it has no horizontal asymptote. So in this situation, it means something like, it does something and then it goes off towards infinity. It doesn't ever level out. It just keeps growing. Okay? Now, my favorite is this last example where we have a tie. We've got 4x squared and we've got 3x squared. Whenever we have a tie in our highest powered thing, we just go to the coefficients. 4x squared, 3x squared, and we make a fraction and say it's going to level out at 4 over 3. So again, if you think about, a graph, maybe here's 1. So you've got this kind of horizontal, this spot at 4/3 where the graph is going to level out, something like that. Okay? So really there are 3 rules you need to know, and that's it. If the highest power is in the denominator, simple. It's just going to level out at the axis, y equals 0. Make sure to write y so we know what kind of asymptote you're talking about, right? Because x equals is vertical, so write y equals. If the highest power is on top in the numerator, well, that means there isn't one. It's just going to keep growing because the top is bigger. In this case, where we have the same power on top and bottom, well, then it's the horizontal line of their coefficients, 4/3. Let's do one more round. So on this first example, here's what we got to do. We got to think about the fact that the top is x, but the bottom, if we were to multiply it out, would be x squared. Now, there are certainly more terms, but the bottom would be x squared and then some other stuff. The highest powered thing is in the denominator. because multiplying out, expanding it, would lead it to be an x squared. So our horizontal asymptote is y equals 0. Highest power is in the bottom. To just explain really quick as we go, why it's always 0 is because we are dividing by something that is getting really, really big at a rate that's faster than the numerator is getting really big. And whenever we're dividing by an ever-increasing number, we just keep getting smaller and smaller outputs nearing 0. All right, next, here we've got an x, and a 2x. So if we multiplied that out, we get 2x squared, and you can see the bottom is just an x, just x plus 7. So in this case, the highest power is in the numerator. So there is no horizontal asymptote. And again, kind of the opposite of the first example, the reason this works the way it does is if the top is getting bigger at a rate faster than the bottom is, well, then we're just going to keep growing. We're never going to level out if the top is increasing or getting big so quickly. Last, we've got 3x and 4x. So if we expanded this out, we would end up with a 12x squared. And in the denominator, we have a 2x and a 5x. That if we expanded that out, we'd get a 10x squared. Well, then the asymptote is, because we have a tie, we're going to say it's the coefficients, 12 over 10, which reduces to 6 over 5. And in this case, it's because the top and bottom are growing at roughly the same rate. The only difference is the top has a slightly larger, in this case, multiplier. So even though they're growing at essentially the same rate with that x squared, we do want to denote with the 6 over 5 that the top has this multiplier that's larger. Okay? So again, the three rules. If the highest power is in the denominator, automatically 0. Highest power is in the numerator, automatically there is no horizontal asymptote. If the highest power is a tie, then we know we have some kind of leveling spot, and we use the coefficients of the highest power to figure out where. If this video helped you, please like and subscribe for more math help.